Hello, everyone. Welcome to this wonderful episode of the Anthropocene and Kerdar Memara, which is an initiative of the EcoCore. And we know the climate change and uh, our construction and architecture industry is more responsible, like 40% of the global greenhouse gas emissions. So today is our first episode, and we have our guest, Mr. Tony, who is a sustainability expert. So welcome, sir. Welcome to the event,
Welcome.
sir.
Thank you. I'm very glad to be here and speaking with you. And um,
Okay.
I can start the presentation if you like to start with your questions. I'm ready anytime you are.
Yeah, thank you, sir. Thank you. So first we will talk about the Anthropocene, like what is this term and how architects are ruining this planet Earth, and along with what are the strategies, like how architects can save the planet, how designer can save the planet.
Yes, the Anthropocene is it's a man-made word. It's anthros, which is Greek for humanity, and scene is the last part. It refers to the era, to the era of the a certain lapse in time. The there's no physical really limits to what Anthropocene is. Like that is to other geological events on the planet. The Anthropocene is pretty much a human definition, and it generally begins with the beginning of agriculture, some say 10,000 years ago. So since the humankind started working the soil. A lot of it started in your part of the world, in the Ganges and in Persia, and also here where I am in the Americas, by the earlier civilizations. There are new findings that agriculture may have started in here some 12,000 years ago. So very early in the modern, say, era of humankind, and then we came from there. You are absolutely right when you said that the let's see if I can find something in here
Yeah.
to share with you.
Okay.
And you were absolutely right that the energy that we use is about is for residential and commercial. And in the picture in there, if we put the two together, 22% with 18%, that's about 40%. It's used by buildings. Then about 30%, 27, 30% is used in transportation. So direct use in running cars and buses and whatnot. And another one third goes into industrial things that are like the computers we are using here right now, and the cameras, and making the cars and making the planes and everything else, refrigerators, everything else that we use in our modern life. Now, for to reduce, so architects can have quite an impact in designing buildings and retrofitting buildings. Now, how it's done, let's pick up, and for reasons that are a little bit more extensive than the time that we have in here to explain in here, let's pick up 8 technologies like solar energy, uh, solar domestic hot water, which is warming up the building with the thermal energy of the sun, for water, for the sink, for the shower, for the kitchen, for washing clothing and whatnot. Then something called composting toilets, we'll explain in a minute. And then a way of recycling the gray water that comes from the sink and the shower and the washing. And gray water is water that does not go through the toilet. So it's very important to differentiate the two. So gray water is mostly it's clean water. So unless someone is very ill in the house, and it doesn't go through the compost toilet, which eliminates already 40% of the water, that 40 to 50% of the water is used in the house. Then organic food production, another technology. Another technology is passive solar design, with natural lighting, ventilation, heating, and cooling. And then the use of non-toxic materials, adobe, straw bale, cob, and other stone, wood. So no plastics, no chemicals, no synthetic chemicals. And collect rainwater catchment. It's about collecting all the water that goes into the building, which is very well known in your part of the world. If you a little bit south of you in Gujarat in India, in the Thar Desert, they have 4-6 inches of rain a year, and they have been collecting water in there from the rainwater for thousands of years. And some of the structures and the technologies that they use, they are still built by their own engineers, much earlier than we had engineers in the Western world, in Europe, or much less in America. And those structures called kunds and other baoris, they are still in use today, and after hundreds and hundreds of years of use. And then wind energy. Wind energy is not suitable for all places, but it can be used. So solar energy is something that can be put together in a system like this. On this is an array, a solar array that's big enough for a very large family. So half of this would be sufficient for a family of 4 or 5 persons, and does not that and that is after reducing substantially the needs of electrical needs on the house, on the building. Then we can use uh, passive solar technologies to um, build the structure. And I'm looking for the slide. In order to build the structure, we have can't we can't here it is. Let's go to the wind, because I see it in here. I don't like these big towers, and for some reason I have a better slide, but because I lost quite a bit of data in this week because of Windows 10. Uh, I don't have the slide at the moment. I don't like these big towers because they are very damaging to the environment, and for reasons that would take a bit to explain. They destroy quite a bit of the landscape. Well, it's very easy to explain. The blades, some of the blades, these ones in here are fairly small. Some of the blades in the wind on these turbines are 150 in modern turbines, most recent. They are about 150 feet long. In order to bring those to the site, you have to build the roads, build the U-turns, make the foundations, and all of that is very disturbing in terms of construction. And the trucks need to make U-turns and need to make a round, so you have to make circles and all of that. And this is done, as it is in many cases, on top of mountains. It destroys the top of the mountain, and it's the beginning of erosion, beginning of erosion and ecological disaster. So the wind needs to be evaluated. That's the main key. Some places may look like they have a lot of wind, but it needs to be evaluated over a long period of time, at least 1 year. Then water can be collected from the roof and placed on a cistern. Recently, I was in Australia, and half of the population in Australia collects water from the rain, and mostly in the outback, in outside of the city, where there is no access to municipal water and things of that nature. So they have uh, round things outside of the home that look like grain silos, but built of metal. But they actually store water, and they are very large, 20,000 gallons, even large. And I saw homes with two, three of those right outside of the home in order to collect all of the gray water. The water that's used in the house can come out through a system like this, and this is a series of three tanks that are filled with gravel, and they are not empty. They are like here on the left side, they are full of gravel. So the water comes in from the left, and it goes to a slightly lower level, and with a system of baffles, the water doesn't come over the vegetation, so the water stays below the soil, the top of the soil, so it does not build mosquitoes, and which are called vectors of disease or disease vectors. So there's very low mosquito to now no mosquito spreading with these things. And the what happens in is that the roots come through the gravel, comes through the ground, and the water passes through, and the roots filter plants like cattails or bulrushes. The roots filter the particles that come from the kitchen after washing food and plants and vegetables and whatnot, and or washing the hands. Now, first thing that needs to be done is to eliminate dangerous chemicals, and one of them is bleach. Bleach is incredibly harsh on the environment. Bleach, as a chemical element in there, is chlorine, and chlorine is very reactive and naturally produces in contact with other hydrocarbons that are always present in water and in the environment. Carbon and hydrogen creates spontaneously creates a large array of chemicals that are called trihalomethanes. There are 200 of them are known to be carcinogen, and this is formed directly into the water. So chlorine should be eliminated in a system like this. And then we can use we are biodigesters as humans, anthropocentric biodigesters, let's call it that way, since we're talking about the Anthropocene. And the mostly that after we eat, and our wastes are about after digestion, our waste, human waste, is about is mostly is water, and 80% or so is water, and the rest is very rich in nitrogen, and that nitrogen can be recycled. Right now, we're just throwing it away into the sewer systems and thinking that we're doing a very good thing, and we're not. We should be composting that human waste and putting it back into the soil. Pretty much a reminder of what native indigenous Americans, the indigenous populations, call it: give it back to the earth, give it back to Pachamama. And because there is, in addition to nitrogen, there's carbon in there, There is potassium, there's phosphates, there is selenium, there is silicon, there is iron, there is cobalt, there is a lot, some 50 different minerals that are essential for the growth of plants. And then that entropy that is generated can go back into the soil, and by the action of photosynthesis, that entropy can be regenerated into food and reestablish the sentence here right in the middle, reestablish the nutrient cycle, because otherwise it's lost. We're doing right now is in our civilization is we send all of that human waste, we send it through the sewer, goes into the ocean, we put chlorine on it, and it's a complete disaster. So architects can alleviate that. Now, at this point, you think that Dr. Tony is a little talking like a mad scientist, but he is not. At the University of British Columbia in Vancouver, that was built recently by a group of architects and engineering, a 30,000 square foot complex, which is something like um, I have to convert that into, but it's a large building. I would say maybe 300 meters by 50 and 3 stories high. So it's a large building, 3,000 square feet. It's a large office complex for a new faculty. And it has 5 Multrum. Clivus Multrum is Swedish, and translated, it actually translates to inclined tank. It was designed, built in Sweden in the 50s, around some 70 years ago. And it's in use there in Sweden, in public buildings. They already require that public buildings have collection of urine, human urine, that is fermented, and then by that process is sterilized and then applied into the fields. And in many buildings as well, they require that to have Clivus Multrum composters. And this is what it looks like at the bottom. That's what the toilet, the restroom looks like. So I wouldn't mind I would like to have one of those in my home. I don't have one yet, but it looks very nice. And it's rated to almost a quarter of a million visits for those 30,000 square foot complex a year. And this is not the only example. Then we have all of this is because we can, with that waste, human waste, we can grow food and reestablish the food cycle, for which we are now using chemical fertilizers that come from oil. So that 40% of the buildings, that the energy consumption and the industrial, it comes from the 30% industrial, 30 some percent industrial use of carbon and CO2. And it took 50 years ago, because of that, it took 50 years just around World War II, 1 calorie of energy to produce 10 calories of food. And 70 years later, because of cheap oil, we are now using 10 calories of fossil fuels to produce 1 calorie of food. That's absolutely the reverse. We're losing 1 inch of topsoil every 15 to 20 years, and it takes 500 to 1,000 years to regenerate 1 inch of topsoil. This is a worldwide crisis, and it's been known already for a while. So we have to reverse that cycle, really a cycle of destruction and wanton use of things around us. And to do that, we really have to educate ourselves. And another thing is that the building can be constructed and built using natural materials, and using, instead of using the huge amounts of synthetic materials, plastics and PVCs and all kinds of synthetic polymers. We can use adobe, which is a block built with sand and clay and some natural fibers that are placed in there. Fibers from, say, from straw, from wheat, from millet, from other plants. There's an enormous variety of plants that give some tensile strength and cohesion to the block. And then it can be reinforced slightly in areas that have earthquake. It is already approved in many municipalities in the United States and in New Mexico, in Arizona, in California, and many other places. Has been a construction for indigenous Americans in here for, again, for thousands of years, and some of those buildings still are functional. Or straw bale, which is the remains of agricultural, the straws from wheat or from rice or from other cereals, or pressed block, and using passive solar design, which is a set of engineering and architectural procedures that reduce the thermal impact and reduce the both in thermal gain during the summer and thermal loss during the winter. And I'll give you some references at the end. So putting a shortening it up, because this is a very long, takes quite a bit of time to explain all of this. Um, it's putting all of those eight technologies together: passive solar homes, solar photovoltaic, rainwater catchment, solar cooking. Yes, we can cook with the sun. I have one slide in here I can show you as well. Solar domestic hot water to warm up the water that is used in the house instead of using gas. A gray water system that we looked in here on number 6, a compost toilet on number 7, an organic garden on number 8. So the house number 1 is built with passive solar techniques and engineering methods. The very simple to use, very cost efficient, does not require any large amounts of capital expenditure. The number 2 is a solar photovoltaic. Natural ventilation here through these openings here in the sky. These are like skylights that allow natural lighting into the house. Natural ventilation here with things that, like, used in North Africa, is called solar chimneys to provide cooling in the summer. Number 5, the solar hot water system. Number 4, the solar cooker can be built directly into the wall. Number 3, a cistern from the roof that collects the rainwater that comes from the roof directly. Trellises here in the front that moderate and control the winter and the summer sun, so the exposure to the house does not heat up too much or cool off too much. And so the food comes into the house, goes into the compost toilet, goes into the organic garden. The water from the cistern goes into the house, goes into the gray water system on number 6, goes into the garden. The food goes back into the house, goes into the compost toilet, goes into the garden again. And this is the cycle of life. This is the way life restores itself. This is the way that entropy can be regenerated by the photosynthetic energy of the sun, and in amounts that are manageable, because at the moment we are generating way over amounts of entropy to the planet that the planet cannot absorb and cannot regenerate itself. So I'll leave you with a few references and where you can find this. Find this paper on the website that I'll leave in the I already gave to Tariq, and I'll leave it again. It's ise-now.com and look for the papers in there. Go to the left side and click on coalition, and then there are three blue links, and click on those. And one of them is this paper, and please download them and read them. There are about 160 references in there. One of them is Sim van der Rijn, a friend and an architect at UC Berkeley. He was chair, and he wrote, being an architect, he wrote a book on toilet papers that are exactly that, how about composting the human waste in the home that comes from the home. And he built, it started building integral design homes in the 70s, and this is one of his books. What I presented in here goes a little bit further than what he presents in there, but this is the beginning of those ideas of building integral design homes. And then ecological design is another that shows the principles of passive solar design. And then Jenkins, he writes again on human waste. Givens writes on early pioneer on organic farming and organic gardening. The Art Ludwig is another pioneer on the use of gray water and how to recycle gray water. Wackernagel is absolutely critical to know, because he is the author of Wackernagel and Rees, William Rees at the University of British Columbia, on the study that led to the metrics of the human footprint, which is vital to understand how far off we are in the use of resources on the planet. And then Herman Daly, which is an early economist also, that pointed out the extensive use of resources by the current thing that we call economy, in the use of resources that way over the capacity of the planet. Thank you very much for your attention, and I'm open for questions or anything that you'd like to ask me.
Thank you, Dr. Tony, for this wonderful presentation with us. And believe me, I learned a lot. Referencing to your photovoltaics, that slide in which you are showing the wind turbines.
Yes.
So we can also have this kind of one of the solution, like we can integrate solar panels and the wind turbines with the building, as we have seen in the Bahrain World Trade Center. If you have seen that building, in that building, the front elevation, we can see the wind turbines on its top. So it is a static element as well, like the part of the elevation, and at the same time it also generate electricity for the building. So if and another, we have the photovoltaic system, like integrated photovoltaic system, in which we can, like we can make the windows glass a solar panel. So at the same time it is a glass for the building and the solar panel as well to generate electricity. So what about that?
There's a good point. What is proposed in here is decentralized power generation. So this is totally integrated with the home. It does not rely on a central power station or on a distribution line or on a grid. This is self-contained in the building itself, in the home itself, in the school, in the university, in the hospital, in the government building. It's decentralized. It's not controlled by corporations. It's not controlled by governments. It's not controlled by administrations. It's not controlled by municipalities. You own it. You generate your own power. You're responsible for it. and you invest as much as you want or as little as you want. Of course, using good sense, everybody would reduce their load in the house. So in the home, in the building, in the university, in the hospital, in whatever, that in the industry, in the factory, we already have some factories that opened here in San Diego, that were totally powered and by solar cells. And what they were doing was actually building more solar cells, the solar panels. So the thing to keep in mind, India, is that every time that you reduced $1 in the use of electricity in the home, in the building, in the factory, it reduces $3 to $5 in total system costs. So reducing $1, say the refrigerator uses too much energy, the lighting uses too much energy. So you reduce $1 in the use per month, per year. You reduce 3 to 5 times. Instead of spending, say, $1,000 in solar panels, you spend $300 in solar panels, or maybe you $200 in solar panels in order to 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 provide the same function. It is critical to understand that. So this is decentralized power and electricity and power, so that is available to anybody on the planet. Wind is a little bit more complicated because wind sometimes blows, sometimes it doesn't, and sometimes it appears, it looks like wind is producing. There's a lot of wind around my home, and it's just a perception. What it needs to be done is that wind needs to be measured for a period of at least 1 year, and there are instruments to do that. It's called anemometers, and that calculate the wind speed and then calculate the yearly average. And that's what's important, is that the year average is a minimum of 12 meters per second minimum in order to produce a reasonable amount of wind energy. Otherwise, you're just spending the money and not getting the energy that you should be getting, and it would be better to look for another solution, like, for instance, photovoltaic. In all, the it's only one of the parts. These two, it's only one aspect of number two. Is only one aspect of the design, and it's an aspect that usually gets a lot of attention. Energy, energy, energy. But it's only one aspect. The thing to keep in mind is that there is a cycle in here, not just the energy that comes from to power the cell phone or the computer or the television inside of the home or the internet, but there is a cycle in here of elements, things that come into the house and goes out of the house. And in the paper that I pointed out earlier, there is quite a bit more on the subject, and this is in there. You can explore the blue lines in here and all the way this all works in order to see the logic and the reasoning and the thinking about building something like that. Over to you.
Okay, thank you for the answer. One more question is that, like in our context, it is very much difficult when we want to convince our customers, our clients, because at the first glance, the sustainable buildings, the passive home look a bit expensive than the cheaper one, because the strategies that you mentioned in this presentation take a lot of money. Because if I say to my clients, if you want to build a house that uh, include the cavity walls and the insulation on your top and the eco bricks in your house, so the question he will ask from me is that it is very much expensive. So these kind of challenges we are facing in our context. Do you have these kind of challenges in your context where you are practicing, and how you are going to solve these?
Yes, yes, the same happens in here, and there are two answers to that. One answer is the persons that already are educated on these matters, and they come to you, and you talk to them for a few minutes, and they ask you about these things that we've just talked, and you can talk to them openly, directly, and say, yes, this we can show you how to do those things. We can guide you and help you in building the things that you're looking for, and you're making the right decisions. Other people that are concerned, like you expressed, that they are concerned about the cost, want the cheapest stuff, you don't sell them the technology. You tell them, would you like to save money? Would you like to have a more healthier environment in your home? Would you like to use less water? Would you like to save on your food? So you don't sell them the technology. Like, don't sell them anything. Just ask them just ask them the question: would you like to save money? How about saving some money? How about saving some a lot of water in your home? And don't tell them what you're going to do. Just tell them you're going to save a lot of water. You're going to save a lot of electricity. You're going to save a lot of energy. You're going to have to save a lot of. Would you like to do? You will have a healthier environment in your building, in your environment, for your family, for your loved ones, for your students, for your patients in the hospital, for whatever places the building is going to be constructed. So those are the answers. Those are my answers. Back to you. Are you there? I think we lost each other. Can you hear me?
Yeah, yeah. Thank you, sir, for this wonderful presentation. And yeah, and thank you again, sir. And that was a very fruitful presentation. So we will meet for the next presentation in the coming days, and initiate something very fruitful for the community, for the Peshawar context, for the Pakistani context. And actually, I'm waiting for my senior colleague, Marwat Khan, who is practicing here for the last 25 years. So it will be good if he share his experience as well. He is just joining.
Okay. Welcome. I see Aziz, and I see Hamid,
Yeah, yeah.
and
Aziz
I
and
see
Hamid are my yeah, they are my student in energy and environment subject, and if they have any question, they can ask freely. Hamid, do you have any question regarding the lecture, or sustainable homes, or energy, or environment? Aziz?
Assalamu alaikum, sir. Sir, I have just joined. I'll ask in the after lecture.
I, I didn't hear the last part. Was that a question?
Hamid, please repeat the question.
No, sir. I said I'll ask questions after the lecture. I don't have any now.
Okay, okay. So thank you, sir. I think we are done.
Terrific. That, terrific. Thank you very much again for inviting me. Lots of good luck. I placed two links in the chat. Please follow up. And we have meetings every Saturday, 2 p.m. on that Facebook link. We meet with a group of global group. You are most welcome to join in. We discussed. It's a focused group, so we discussed pretty much these technologies and how to implement them, both in the technological and engineering and architectural aspects, but also in the aspects, socio-economic and political aspects that we face to promote, to develop the social conditions that we can start reducing the human footprint. So that is on those three papers that that's on the first link. Please download them. Please read them. There is a lot of references in there. Go to the library, check them out online. And there's quite a bit of material in there. This is not something that it will become clear in an half-hour lecture or so. It takes quite a bit longer than that. So good luck to y'all. Stay in touch. Stay in contact. This is great work that needs to be done, and we need to reduce the load that the Anthropocene is right now imposing on the planet, on Pachamama. Good night to you all.
Yeah, sir, you said very good because we believe that architects do have a role in the protecting the planet Earth, and if we are building in such a way like consuming the energy, and we are designing such building in a traditional and typical way, then I am sure the planet Earth will like we will be search for another planet, because the field, the profession that we belong, the architecture, is more responsible for the energy consumption for the global greenhouse gas emissions. So I think if we train architect, because the architect need to be involved and take to on board on these kind of sessions, because they have the power. The architecture have the power to improve the communities, to improve the cities, the buildings, and I'm sure if a lot of change will happen. Marwa Khan, our senior architect from Peshawar, who has practiced here for more than 30 or 25 years, will also share his experience. He is also here. Marwa Khan sir. Sir Marwa, kindly unmute your mic, please, if you want to thank our guest and ask any question regarding the basic homes.
Thank you very much for informing me about this program. Thank you to the guest, Solar Tony and Tariq Saab. I haven't see the whole program because of the late coming, but you are presenting a very interesting topic, because the coming years, the coming age is the age of sustainable energy and solar energy. So I haven't question to ask from the Solar Tony, because I haven't listened to him, but I may share with you that if this person serve us more and more, we may learn about the solar energy and the sustainable energy, renewable energy, and we may take advantage, benefit from his experiences and knowledge. Thank you very much. Thank you, Tariq.
Thank you, Marwa. Thank you very much for your kind words. The presentation and this event was recorded, so it's a very succinct, very short presentation. It goes through the major points into building a structure like the one that's on the screen right now, that has 8 technologies. In addition to solar, solar is often regarded as a major component. I don't particularly see it as a major component. There are other on the reduction of energy, not just from solar, not just from energy, electricity itself. So there's solar hot water at number 5 in this picture. There's number 2, which is the photovoltaics, but there is also number 1, which is a home built with passive solar energy technologies. And number 3, the collection of rainwater from the roof, is something that has been done around the areas where you are in northern India for thousands of years. Number 7, which is a compost system for the bio waste that humans generate, that now is polluting our rivers and the land and the oceans, because everything is mixed up and then throw into the environment. And then number 6 is a gray water system to clean up the water. Number 8, to restore those entropies that come from the home and regenerate those through the photosynthetic energy of the sun. So this is a thermodynamically stable, metastable system that can bring us to a system of a status, a state of entropy that the Earth can accommodate without being overwhelmed. I left 2 links on the chat window to the right that you are welcome to go to them. And on the first one, there are 3 papers. And in one of them, the first one has quite a bit of this explanation of what was in here, and also quite a number of references in there, about 150 references in there. And another third paper where I propose the creation of a faculty of eco-sustainability, and one of them would be a faculty of eco-sustainable architecture, or eco-sustainable engineering, or eco-sustainable, not just sustainable, but we have to find a way that has to be ecologically sustainable. We have to find a balance that ecologically maintains the integrity and the health of Pachamama, of the planet, of Mother Earth. So I also hereby acknowledge that I'm standing on the land of the ancestors of the Tongva people, which were the original owners of this part of the Americas. And I'm standing and I honor their memory and their ancestors. So good night to you all, and hope that we can stay in touch and further this work, and because it's a very necessary work to educate the new generation of architects and engineers and cadres and everyone else, educators on the planet, if we are going to succeed and remain here as human beings on the Anthropocene and further on into the future. Good night to you all. Thank you very much. Thank you very, very, very much.
Thank you. Thank you so much.
Thank you. Hello, Tariq.
Hello. I'm logging off.
I think there is night at your side, huh?
Yes, it's getting close to midnight. Yes. What time is it where you are?
Here is 11:30 a.m. Day. There is a day.
11:30. So we are about 12 hours difference. I am to you. We are. I am to. You are in the you are in the morning. I am in the evening. From the I think the previous day.
Here is morning. Yes.
Here is still
Uh,
here is still Sunday night.
Sunday night.
Sunday night, yes.
Yes, we can contact with you on Sunday, and this is a very golden chance for us also to be here with you, and we want to take advantage from your experiences and your knowledge, and
Yes,
also want to share practical knowledge. If you can help us, or we can help you in introducing the technology practically in the market. We
that's terrific. I'm absolutely open to that, and also we can collaborate on
we can
research, on writing papers, on the proceeding projects as we get to know each other. I'll show you some of the things that I'm involved in doing. I'm open on this channel, and Tariq also has my meat place, but he has my email. So he
Yeah,
has my Facebook. So you can send me a short message on Facebook when you like to meet,
yeah,
and if I'm available, most glad to do that. So we can meet
yeah,
in here and or on Facebook or on one or the other. So
yeah. Absolutely. We will in contact in touch with you. This is my first time to talk with you. I will talk to Tarek, and we will arrange a presentation or meeting, inshallah, in detail on Sunday or any day with you, inshallah.
sounds terrific. Thanks, Marvat. Thanks, Amit.
Thank you. Thank you.
Thanks for your attention. Tariq is already left. Uh, that's either this is a good time. So it is getting close to midday. So if you start at 8 o'clock in the morning, it's 8 o'clock in the evening for me.
Yeah, yeah,
So
yeah.
it's a good time. It's a good that's so from 8 a.m. to 12
Yeah,
p.m.
yeah, yeah,
to midday. It's a good time for you. It's a good time for me. So we can
yeah, yeah.
get in touch during those times. Otherwise, on and I invite you all, Tariq and Marvat and Amit, everybody that was here, and anyone that you showed the recording. I'll invite you to join in on the link that's on the chat, on the Facebook link. Just
Uh,
join in, attached in there, and we meet with a global group of architects and engineers and people from around the world, from South America, North America, Europe, Africa, everywhere, Australia. That
right.
we want to we are working on developing eco-sustainable communities. So design based on the things that we discussed here today. So it's
Of-
on Saturdays. I'll put it
Yeah,
on the Saturdays, 2 p.m. Pacific Standard Time. So I put it
right.
on the chat on the right. So we meet there
I,
once a
I,
week.
I, I will take a link from Tarek, and then I will contact with you.
2 p.m. The only thing is that 2 p.m. in the afternoon, 2 p.m. in the afternoon is 2 a.m. your time.
Yeah,
It's 2 in the morning. So it's a little bit, it's not easy time for you. It's in the middle of the night for you. So it's
yeah, yeah.
fun.
We will manage. We will manage.
Okay. It's a little bit in the middle, but it's a Saturday night, so it may work. But if we could try maybe because it's also because the Europeans they like to join in, so it's already late for them. It's a little bit difficult to manage the time that accommodates everybody. But we'll see. We'll see. Maybe we'll have a new time. Good
Yeah,
night.
yeah.
Good night to you all. Very very glad to that we had this
Good
conversation.
night. Thank you very much. Thank you, sir. Thank you.
Salam alaikum.
Wa alaikum assalam. Alaikum. Thank you,
Wa
sir.
alaikum
Thank you.
assalam. Thank you, sir.